Hi, this is Ranjit from Cybersecurity A section, double two nine five nine six two six five roll number. Today's topic is absorption properties of modified zeolite. Introduction. Because the stringent nutrient levels are being required in effluents to protect water bodies. Removal of nutrients from discharged water has been required in many water treatment plants. Ammonia nitrogen in the effluent has harmful effects on water resources. Thus, wastewater with high ammonia concentration must be treated before arriving at the receiving water. The three most widely used methods for removal of ammonia from polluted water are air-stripped ion exchange and biological nitrification denitrification. The ion exchange method is preferred over the other methods since it is stable, suits automation and quality control, and is easy to maintain. As a kind of aluminum silicate minerals with a framework structure, zeolite has a high cation exchange capacity and high ammonia selective properties. Furthermore, it can act as an biocarrier for nitrification bacteria which oxidize ammonia to the nitrate anion. Zeolite is a natural mineral that has been known for their ability to remove ammonia from polluted waters. In this weapon, zeolite is used for adsorption the ammonia from wastewater. Moreover, chemical and biological regeneration for ammonia removal was investigated. This study especially estimated to 1. Modified zeolite properties such as SEM, chemical integrated and surface analysis. Second one, modified zeolite and biofilm modified zeolite for ammonia adsorption and ion exchange. Here are some tables. Table 1, chemical analysis of modified zeolite. Consistent. SiO2 is 70.03, Al2O3 is 15.78, Fe2O3 is 0.37, CaO is 2.65, MgO is 0.38, K2O is 9.55, Na2O is 1.77. Table 2, raw water quality in experiment. Parameter, average mg per liter. pH 7.0 to 7.6. COD 40 to 100. BOD 5 15 to 50. SS 15 to 60. NH4 plus minus N 20 to 40. Materials and methods. A. Materials and wastewater quality. The virgin zeolite used in the experiment was produced by Helen of Hylangian Proviant. The chemical analysis of virgin zeolite sample is given in table 1. The wastewater used in this project was from Harbin University of Commerce. Residential area was the wastewater, and the average wastewater quality as shown in table 2. Experimental laboratories. The system is composed of the following items: 28 liters reactor made from 200 mm diameter transparent PVC pipe. The reactor is filled with 2000 grams modified zeolite. Under the modified zeolite was gravel bed with height of 100 mm. An acrylic plate was placed in the bottom of the column to support the modified zeolite and distribute backwash water and supply air. See. Experimental methods. During batch and continuous experiments, the ammonium nitrogen adsorptive capacity of virgin modified zeolite and biofilm covered modified zeolite was examined. The continuous experiment shown as figure 1, the DO ammonia films influent and effluent was measured respectively by adopting the Chinese EPA standard methods. Preparation of biofilm covered modified zeolite. Firstly, the activated sludge was pumped through the modified zeolite column for several cycles. Then the column operated in a batch mode, and air was supplied for 3 days when the biomass was found on the surface of modified zeolite. The influent solution was shifted to cultured solution. The conditions were controlled as follows. DO was maintained at. This is the diagram of schematic diagram of the continuous experiment. Results and discussion. Sum of modified zeolite. It can be seen from figure 2. The structure of the modified zeolite was very compact and there was lots of cavities and multitudinous holes with medium and macro pore diameters, and the pore diameter was mean. Such would be useful to help some ions such as NH4 plus enter into the pore in the zeolite, or it was attachable as the carrier for the nitrifying biomass. Moreover, the ion exchange and chemical absorption could be happen in the zeolite. Chemical ingredient and surface analysis. To investigate the main context change after modified methods, the chemical ingredient was analyzed of metal oxidants. The results were shown as table 3 because the cation NH4 is very to exchange with Na plus and Ca2 plus in zeolite, while the K plus cation cannot exchange with Na plus and Ca2 plus, as can be seen from figure 3. After modification, the content of Na plus and Ca2 plus in zeolite increased from 1.77% to 2.6% to 2.65% and 2.92% respectively. This is the photo of some photo of modified zeolite. Table 3. The chemical ingredient of modified zeolite. Si content SiO2 is 67.99, PiO2 is 0.23, Al2O3 is 13.25, Fe2O3 is 0.67, MgO is 0.16, CO is 2.92, MgO is 0.89, K2O is 1.27, Na2O is 2.65, P2O5 is 0.013. Table for the surface analysis of combined modified zeolite. Diameter, bed surface 3 to 10 6.88, pore volume 0.0195, mean pore diameter 114.33. For 1 2 3 7.59, pore volume 0.0211, mean pore diameter 166.45. Lesser than 1, bed surface 7.95, pore volume 0.0299, mean pore diameter 186.49. This is the graph about the metal oxides content in zeolite before and after modification. The blank bar shows before modification, the designer bar shows after modification. But the content of K plus in zeolite decreased from 2% to 1.27%. This is the reason why the ammonia capacity of modified zeolite increased sharply in microscale. The surface analysis of modified zeolite was investigated by bit standard methods. The result was shown in table 4. As can be seen from table 4, the properties of zeolite pore system are lots of difference from some other pore materials such as activated carbon usually used in water treatment process because the pore system of activated carbon was very complicated with the surface area of 1000 meters square per g, 300 meters square per grams, which consist of micropores, mesopores, and macropores. So, the activated carbon has a porous micropore structure. Compared with activated carbon, the surface analysis in table 4 shown that the pore system of modified zeolite after modification was simple, and the pore diameter was middle pore with fewer surface areas. These characteristics of modified zeolite have disadvantages of physics absorption, but due to the diffusion pressure in the pore decrease, the structures of modified zeolite would be helpful to carry out ion exchange. The ammonia adsorption experiment, batch experiment. Table 5 data of adsorbed ammonia by virgin modified zeolite during static experiment. Number Ori- original concentration 150, 200, 3, 150, 4, 200, 5, 250, 6, 300. Equilibrium concentration C 1 12.20 to 31.20, 3 45.10, 4 80.60, 5 110.10, 6 153.60. Ammonia absorption capacity Q 1 3.78, 2 6.88, 3 10.49, 4 11.94, 13.99, 6 14.64. 1 by C 181.97, 2 32.05, 3 22.17, 4 12.41, 5 9.08, 6 6.5. Table 6. Date of observed ammonia by the biofilm covered modified zeolite during static experiment. Original concentration 150, 210, 3 150, 4 200, 5 250, 6 300. Equilibrium concentration C 14.20 to 40.20, 3 55.10, 4 91.60, 5 124.10, 6 169.60. Ammonia absorption capacity Q 3.5 years, second one 5.98, third one 9.49, fourth one 10.84, fifth one 12.59, sixth one 13.04. 1 by C. First one 70.42, second one 24.88, third one 18.15, fourth one 10.92, fifth one 8.06, sixth one 5.90. The ammonia absorption capacity of virgin modified zeolite of a biofilm covered modified zeolite were shown in table 5 and table 6. As shown in table 5 and 6, when the ammonia concentration in the solution increased, the ammonia absorption capacity of virgin modified zeolite and biofilm covered modified zeolite was also increased. According to the Langer isotherm, is always employed to describe the ion exchange process. So in this paper, such as ammonia exchange properties were decreased by longer isotherm. The longer isotherm is defined as Q is equals to ABC by 1 plus BC. Question mark. So Q is the amount of NH4 plus exchange per unit weight of modified zeolite. C is the NH4 plus concentration in the solution. The values of A and B are model parameters. A is the maximal NH4 exchange per unit weight of modified zeolite. B is the Langer energy constant. Usually one also can be rearranged as follows. 1 by A is also 1 by A plus 1 by ABC. The data of virgin modified zeolite and biofilm covered modified zeolite gave good fit of Langer isotherm. Two Langer isotherms were good linear form and the linear form related coefficients were 0.9895 and 0.9674 respectively. The results showed that the data obtained from batch studies were fit to Langer isotherm for ammonia ion uptake onto modified zeolite. According to Langer isotherms, the maximal NH4 plus exchange per unit weight of virgin modified zeolite was 20.39 mg, and the maximal NH4 exchange per unit weight of biofilm covered modified zeolite was obtained 16.75 mg. It was concluded that no significant differences in the absorption capacity were detected between virgin modified zeolite and biofilm covered modified zeolite. Second, breakthrough experiment. Figure 4 presents the result of the breakthrough probe with the ammonia nitrogen concentration of 20 mg per L at a hydraulic loading rate of 2m3 m2h. Figure 5 presents the results of a breakthrough curve with the ammonia nitrogen concentration of 10 mg per L and hydraulic loading rate of 8 m3 by m2.h. As can be seen from figure 4 and figure 5, the hydraulic loading rate is decreased from 8 mg per meter square to 2m3, 2m cube per meter square. Although the inception infant ammonia concentration increased from 10 mg by liter to 20 mg by liter, the breakthrough value was 560 BV in the virgin modified zeolite and 530 BV in biofilm covered modified zeolite respectively. The results showed that longer retention times caused the similar ammonia absorptive capacity with virgin modified zeolite or biofilm covered modified zeolite. The modified zeolite did not lose its absorption capacity in spite of the biofilm covered. This is a diagram of this is the graph showing bed volumes, and this is the another graph showing bed volume of NH4 to an effluent between biofilm covered zeolite and virgin modified zeolite. Breakthrough curve with hydraulic load of experiment. This during the ammonia adsorptive experiment, the results of batch and breakthrough experiment showed that the difference of ammonia absorption capacity between biofilm covered modified zeolite and virgin modified zeolite was not obvious. Conclusions. Some of modified zeolite showed that there were lots of cavities and multitudinous holes with medium and macro pores diameters. Such would be useful to help some ions such as NH4 plus enter into the pore in the zeolite, or it was attachable as carrier of the nitrifying biomass. The chemical integrity and surface analysis of modified zeolite showed that after modification, the content of Na plus and CO2 plus in zeolite increased from 1.77% and 2.6% to 2.65% and 2.92% respectively, while the content of K plus decreased from 2% to 1.2527%. The pore system of modified zeolite was simple, and the pore diameter was middle pore with fewer surface areas. This structure of modification zeolite would be helpful to carry out ion exchange. The result of batch and breakthrough experiments showed that the difference of ammonia absorption capacities of virgin modified zeolite and biofilm covered modified zeolite were not obvious. Thank you, everyone.